Hello and welcome to Security. This is a continuation of the AWS hands-on labs, and today I'm going to be showing you network access control list, which are the subnet level firewalls in AWS. I'm going to be showing you how they operate and how, unlike security groups, they have a stateless nature. So let's get right into it. So the first thing I'm going to do is launch an instance. I'm just going to go to my instances and under EC2 and click on launch instance, select the Linux 2 AMI and the T2 micro instance type. Leave instance details as default. Click on add storage, leave as default, add tags, and I'll give it a name. So I'll just give it the name NACL test. So I'll click on next to configure security groups. And I'm going to create a new security group, which I'll give the name ping SSH access, because this security group is going to allow SSH and ping access. Okay, so there's already a security group rule for SSH access. I'm going to add a rule for ICMP as well, because I want to allow ping access to the instance. And so I'm going to select custom ICMP rule, IPv4. And for protocol, I'm going to say echo request to allow ping request from any source to the instance. So I'll select source as anywhere. I'll go on launch, and I click on launch. So I use my existing key pair as well and just launch the instance. So now my instance is running. I'll click on view instances. So you can see it in the pending state. I'll just pause the video and come back when it's done booting. Okay, so now my instance is done booting, so I can connect to it. So I pull up the git bash terminal and I select my instance and click on connect to connect to it. So I go to SSH client, so I can get the command basically that I can just copy and paste in my terminal. So I copy the command, then I pull up my git bash terminal one more time and paste it in. First of all, I need to go to the directory where I downloaded my key. Go to my downloads directory and paste. Oh, I need to copy the command again, and I paste in the command and say yes to accept the fingerprint. And now I am in the EC2 instance. So now, if I ping google.com, I'll be able to ping from my EC2 instance, and this is because by default, security groups allow all traffic out of your instance, and also by default, your instance is in the default VPC, which has the default NACLs applied to it as well. And the default NACLs in the default VPC basically allow all traffic in and out from your subnet. So let's pull up the VPC service to see how this operates. So you can manage NACLs under VPCs because they operate at the subnet level. If I click on network ACLs under my VPCs, you can see that I have a default network ACL that all my subnets are associated with automatically and by default, and it has 2 inbound rules and 2 outbound rules. I can see the inbound rules that allows all traffic, and the one that denies all traffic implicitly as well. So there's an explicit rule and an implicit rule. So basically, if nothing is specified explicitly, network access control lists are going to deny all traffic automatically or implicitly. So another difference between network access control list and security groups is rule numbers. And network access control lists give preference to rules according to their numbers. The lower the number, basically, the higher the preference for the rule. But security groups always read through the whole list and only make a decision after going through all the rules. For network access control list, read the rules according to the rule numbers from the top to bottom and make a decision on the first match. So now we can see how network access control is behave by default when they just created. I'm going to create a new one. I'll call it test NACL, and I'm going to link it to my default VPC and just create. So now it's created. You can see if I select the group I just created, network access control list I just created, you can see by default it only has the implicit denial rule that blocks all traffic. So if I apply this network access control list to a subnet now, it's going to block all traffic to that subnet. So now all my subnets are associated with the default network access control list. You can see the 3 subnets in my region, or the 3 availability zones. Availability zones are also subnets in my region. So VPCs by default would create different subnets in each availability zone. So next I'll check what availability zone my instance is currently in, so I can link the availability zone to my new NACL. So you can see it's in the CA Central 1A availability zone. So I'll go back to my NACLs and I'm going to edit subnet associations for this test NACL. I'm going to select that availability zone, the CA Central 1A, and save changes. So now that subnet or the availability zone is now linked to the new test NACL. You can see the default NACL has, instead of 3 subnets, now has 2, and one of them is linked to the new NACL that I just created, which is a test NACL. So, and you can confirm as well that the inbound and outbound rules are basically denying traffic right now, denying all traffic. So now let's pull up the terminal to see what this new setting has cost. So we can see that basically the connection is not responding anymore. In fact, it's going to reset very soon because the instance is no longer, connections from the instance are no longer being sent out. So you can see the connection has been reset, and that's because of this new network access control list rule that we have. Network access control list with the rule that is blocking all traffic. And if I try connecting again, it's not connecting because no traffic is allowed out of the instance, or either out or into the instance. So I have tried the command to try and connect to the instance, but it is not connecting to the instance. It's timing out basically. So that was SSH. But also, if I try to ping the address of the instance, I just copy the address and try to ping it. It's also going to fail. So I try pinging it, and you can see it keeps timing out as well because the network access control list is blocking access, even if the security group, the instance level security group, is allowing access. On the subnet level, the network access control list is blocking all access to this my instance. So now back to my network access control list. I'm going to edit my inbound rules, and I'm going to add a rule that allows echo replies inbound to my instance. So I'll give it the rule number 100 and select custom ICP IPv4 and leave the source info as anywhere. And the action I want is for it to allow traffic from anywhere. So for the protocol, I'm going to select echo request, which means that ping requests to this instance now should be allowed. So I'll save my changes and I'll try to ping the instance again. So yeah, if I check the inbound rules now, you see ping requests are allowed to the instance. So yeah, when I try to ping the instance, you see it's still timing out. And that's because of the way network access control lists work, which is different from the way security groups work. Basically, their stateless nature means that for any traffic to be allowed, there has to be both inbound and outbound rules allowing it. So in order to be able to ping this instance, I need to add an outbound rule that also allows the instance to send out ping responses. So I'm going to add a rule with the number 100, and I'm going to select custom ICMP IPv4, and this time it's going to be echo reply, and I'm going to save changes. So now we can see that my NACL has an outbound rule that allows the echo replies out of the subnet. So I'm going to try pinging again. And when I try pinging, you can see I'm getting a response now from the instance. So the next thing I'm going to demonstrate is how NACLs use rule numbers. And for that, I'm just going to allow all outbound traffic on the NACL. So now I have the outbound rule set. In my inbound rules, I'm going to add a new rule. So I click on Edit Inbound Rules. So now I'll add another rule with the rule number 200, and I'm going to copy the exact same rule as the rule number 100, but this time with the action deny. So I have rule number 100 allowing echo request and rule number 200 blocking echo request. So when I ping now with my terminal, I'm still getting responses, and that's because of the priority of the rules on NACLs. The lower the number, the higher the priority. So what I'll do now is edit my rules again and change the rule number from 200 for the deny rule to 50, and you'll see what happens. So now when I try to ping the instance, the request is timing out. Basically, this rule is blocking the request. And basically, this is because the rules are read from top to bottom in ascending order of priority, and an action is taken based on the first match. So next, I'm going to demonstrate how NACLs work by connecting to the instance and observing the behavior from the perspective of the instance. So I'm going to delete the deny rule and change the rule 100 to allow SSH access. So now I have inbound rules that allow for only SSH access to the instance. So next, I try to connect to the instance, and I'm connected successfully because my inbound rules accepts SSH traffic and the outbound rules accepts all traffic. So what I'm going to try to do now is ping google.com from the instance, and you can see I'm not getting any response, even when the outbound rule allows all traffic out of the instance. And this is because NACLs are stateless, and for ping responses to be allowed, there has to be an inbound rule specifically allowing them into the network. Okay, now I'm going to add a rule that allows ping replies, that is some ICMP echo replies into the network. But let's just pretend I made a mistake and allowed echo request instead, and let's see what happens. So when I pull up my terminal, I try to ping, and you can see just that little mistake still makes my network not function the way I want it to function. I'm still not receiving the ping responses or the echo replies to my instance, even when there's an ICMP rule that's allowing echo request rather than echo reply. So what I'm going to do now is change it to what it's supposed to be. And if you see the rules now, I have a rule that's allowing echo replies. So now the ping should work properly. And when I ping google.com, I'm getting my responses. So that just shows how important it is to be very careful when you're configuring networks. Something as simple as allowing echo request where it's supposed to be echo replies can basically affect the function of your network. So the next thing I'm going to demonstrate is ephemeral ports and how they work with network access control list. So the first thing I'm going to do is edit my outbound rules to allow only SSH traffic rather than all traffic. So I go to my outbound rules, click on edit outbound rules, and change it from all traffic to allow just SSH traffic. So I select SSH, and now only SSH traffic is allowed out of the subnet. Okay, so now you can see I have an inbound rule that's allowing SSH traffic and an outbound rule that's allowing SSH traffic, but my SSH connection has basically been lost. It's been reset by the host, and that's because of ephemeral ports. So ephemeral ports are ports that are open temporarily, usually at the client side of your client server connection that is used to connect to the server. So when you're connecting to a server, for example, at the server side, there's going to be a well-known port that you connect to from your client PC. And on your client PC, an ephemeral port is a temporary port that's open that allows you to connect to the server on the well-known port. For example, for a web server, it's going to be port 80 or port 443 for secure HTTPS, which is used more often today. So but on your client side, there's a port that's open to connect to the server, and that port is usually in the range of 1024 to 65535, which is a port range for ephemeral ports. So the reason the connection is failing is because although I'm connecting to the instance on port 22, which is the SSH port, my computer is not connecting to the instance using port 22. I mean the port on my computer that is sending the connection to the SSH port on the instance is not port 22 but an ephemeral port. So because my outbound rule now is currently allowing only outbound connections to port 22, which is also the SSH port, my it is not allowing an outbound connection to the ephemeral port on which my host PC is communicating. So basically, the connection back to my PC is not allowed out of the network. So to fix that, I have to allow ephemeral ports, and I will just edit the outbound rules now, specify the port range for ephemeral port, which is 1024 to 65535, and I save the changes. So now I should be able to SSH back into the instance. So I pull up the terminal and run the command once more. And yeah, I'm back in the instance now. Okay, so this is the end of the lab. I'm just gonna start the cleanup. But today we've learned how network access control is work on AWS, and we've looked at their stateless nature. We've also looked at how there's a priority given to rules based on the number. And finally, we looked at ephemeral ports and how they operate as well. So as usual, please like and subscribe. If you have any questions, leave it in the comments below and I'll get to it as soon as I can. Thanks for watching and I'll see you in the next video.